Hello, my name's Mr. Tinkler, teacher in Newport. Been teaching for 25 years, doing additional maths for 12, 13, 14 years. And so this is just a recap session based on the three I've done so far this term. Included in here are lessons on completing the square, factorising quadratics, factor and remainder theorem. Now, some of the slides are the same ones I used in session 5, 6, and 7, but every single one of them I've added the brand new questions or to the last three papers. Of questions. So there will be brand new questions as well as originals you would have seen before. The first one, I'm just doing some completing the square work. And as I say, it's just a recap. So the first thing I've done, I've halved 6 down to 3. And then I have to do 3 squared. If I forward this out, box grid out, method out, it'd give me an extra 9. So I take away the 9 to counteract this 3 squared. It'll always be a subtract no matter what sign is in there. Plus 10 on the end. As my slide says. And that will give you that number. And that'll be completing the square. And we'll find a question later today where we do a little bit more on completing the square. Simplified. Now these two are different. Again, we've got a -4 in the middle. Half of -8 is -4, but it's still -16 because when you square out -4 all squared becomes +16. So you take away 16 to counteract it. And as the slides here on the side, it'll show you what you have to do. And same with the next two. Okay, so that's the recap. So if you follow the steps, it says on the right hand side, it's pretty straightforward. These complete the squares are quite nice on additional maths. A level, they're definitely a bit harder. You find that out when you're in year 12. Now, for additional maths, when completing the quadratic, as I say, this goes on, it will only have x squared in the front. It will only say x squared. It won't say 1x squared, but it'll just say x squared. And some A level are like that, but most of them have a number in front. Sometimes they have a minus. Okay, as I've said, there's always been a whole number. So here's a past paper question on completing the square. And this is one you will have seen if you've watched session 5. Okay, think about halving it. I'll give you a minute or so. Okay, so half of 12 is 6. Don't forget, you've got to counteract that 6 squared by taking away 36 and add 49. Now, on the previous slide, it just says to simplify. This particular question asks something else, the least value. The least value you can possibly get is 13 from this 13 here. What is the value of x when it is? So to make it that, you've got to get x plus 6 squared to be as low as possible. The lowest you can get from any squared number is 0. And the lowest that will be, as we'll say now, is at -6. Why? Because x plus 6 all squared has to equal 0. X plus 6 has to equal 0. So x has to equal -6. So the next thing, I'm doing a quick recap on session 6, which is factorising quadratics. Now, as I said in my previous presentation, there will be lots of different ways of factorising from your schools. And I'm not saying that you should follow this method, but we use this method in my school to help us with the factor theorem, remainder theorem, what we do additional maths and at A level. So I remind you what we do, the idea of smiles. It's going to start with 3x and x to make 3x squared. The numbers on the end are going to have to multiply to 2. So it could be 2 and 1, or it could be 1 and 2. And then downside with this over other methods you might have been told, some of it you have to do a bit of trial and error until you get there. Now, if we put -1 in, we get -1x from that smile, which means we'll have a +2 on the other side. -1 times +2 is -2. So from that smile, we get 6x. And in the answer box is 5x. And if you're wondering where the 5x comes from, it comes from this 5x here. If that hadn't given us 5x, I know we would have gone wrong. Okay, from that 5x, if it hadn't given us 5x, say if I'd done 2 and -1, so if I put 2 here and I put -1 there, I would add 2x and -1, it would have been 2x and -3x, and you can't get to 5x from 2x and -3x. So here's an additional maths question. Try yourself. Not the easiest one because it starts with 15x squared. For all the years I've been teaching, generally I always try 1 and 15 or 5 and 3, but I was generally find out you're always better off choosing the two middles and the numbers in the middle, so 5 and 3. So I'll give you a chance to have a go at that question yourself before putting my answers on. Okay, so I'm definitely going to start my bracket with 5x and 3x. And number 8, I'll be looking at 1 and 8 or 2 and 4. But again, generally I choose the two numbers in the middle. So I try 2 and 4, and if that doesn't work on the smiles, then I do 4 and 2. So I'll show you what that works out as. 5x, 3x, 2 and 4 will multiply to 8. 2 3s make 6, and 5 4s make 20. Now how can I get to minus 14 from this? From 6x minus 20x. 6x minus 20x will give me minus 14x. So I know it's right. If I put 4 and 2 the other way around, I would add 4 3s are 12 and 2 5s are 10. There's no way I can make 14 or minus 14 from 12 and 10. Hence solve. Now there's lots of shortcuts here. I'm not a big fan of shortcuts, but some people might tell you just to do the opposite signs. Basically the opposite of plus 2 is minus 2 and the opposite times by 5 is divide by 5. That's where I got the answer from. But I'd rather show you where they come from. 5x plus 2 equals 0, because it did say solve it when it equals 0. If it said equals 7 on the end, which you've all seen in GCSE maths, you'd have to get rid of the 7 by taking away 7 from both sides. If it says equals minus 42, you'd have to add 42 to both sides. And then 3x minus 4. So this is the same as you would have done at GCSE maths. It's just a little bit harder with the number in the front. Neither of them are prime numbers. The first one or the last one. Okay, so that's a little recap there, and you will see some more questions on here. And the reason why I did that as session 6 was really for leading into this session 7 one. Factor and remainder theorem. So some questions, I think I'm right in saying last year's additional maths paper asked to show something was a factor, and also asked it to show what the remainder was. I think it was over 100. It was a bit of a strange number. When I did it myself, I thought, oh, that's a bit high. It was the right answer. It might be 101. But you may be asked to find the remainder of a polynomial. Polynomial means just many powers. After being given a factored expression, substituting in and then remainder. If the answer is 0, then there's no remainder, which means a factor has been found. 5 goes into 20 with no remainder, so 5 is a factor of 20. 7 doesn't go into 20 without a remainder, or it does have a remainder, so it's not a factor. I'm going to go back to some of your basic maths to get your head around that. Next one. So, are these factors? Is x minus 1 a factor? Now, the classic mistake people make here is subbing in minus 1. You don't, you sub in 1. X minus 1, the reason why you sub in 1, because you're looking for x minus 1 to equal 0, and that will be when x equals 1. So when you substitute in 1, what answer do we get? Here's all the steps. And you should show those, because you could do it all in your calculator and you can make it up. Particularly the question when it says show that it's a factor, no one just put straight 0. So this one does say it's 0. So x minus 1 is a factor. Find the remainder. Now this one tells us straight away it's not a factor, so it tells us straight away we're going to look for a remainder. So it won't be 0, and if it is 0, I'd probably go back and check the question again. Now x plus 1, but we're not subbing in plus 1, we're subbing in minus 1. Same reason I said in the last one. X plus 1 equals 0, so x equals minus 1. Now be careful when you substitute minuses in your calculator, you need to put your minuses in brackets with the power outside the bracket. Gives us the answer of 8. So the remainder is 8. Fairly straightforward. You'll sometimes see that on A level as well as additional maths. What would I have done personally? I would have just written this line and then I would have gone straight to the answer and said E equals remainder of 8. Now, this next question, though, doesn't tell us any factors. So we're going to have to find a factor. Now, normally on the additional maths paper, they will tell us the first factor or lead us into it by proving something is a factor. But if they don't, you're going to have to try numbers. And the numbers must have to divide into 10 on the end. So I would try 1, 2, 5, maybe 10. But maybe then I'd try 1, 2, minus 1, minus 2. All the years I've been teaching, generally, it seems to work after 1 or 2 or minus 1 and minus 2. But if it doesn't work, They have to be numbers that can divide into 10. So this time we're going to try f is 1. We'll try if 1 substitutes incorrectly and gives us a factor, which means it'd have to give us an answer 0. Doesn't. It gives us minus 10. It's not minus 10. It's well, yeah, it is minus 10, so it's not a factor. Excuse me. X minus 1 is not a factor, so there's no point in carrying on any further with that one. So I'm going to try 2 next. And it does give us 0. So x minus 2 is a factor. And it's the same reason as I said before. If it's f of 2, that means x minus 2 is a factor because 2 minus 2 gives us 0. So now we know our first factor. Now, that's shown us how to find a factor. This one I'm actually going to show you how to factorize it. So this type of question, we've been told x minus 2 is a factor straight away. So the next thing, I will split this whole expression into a smallish bracket and a bigger bracket. In the bigger bracket, I'm going to have, you see it's wide, I'm going to have room for an x squared term, an x term, and just a constant term on the end. So how do we do this with our smiles idea? Well, first of all, x times 3x squared gives us 3x cubed. Then you look for the last number. You leave the middle bit, the tricky bit, to the end. Minus 2 times minus 3, or minus 2 multiplied by minus 3 is plus 6. So that looks good. Now, from our smiles, this gives us a minus 6x squared. And in the answer box this time, we want to have 2x squared. From this bit, I work on the x squared. This will also work if you work on the x term. I just have always worked on the x squared term. Stands out more for me. So we put 2x squared in the answer box. And how do I get from minus 6 to plus 2x squared? I'd have to plus 8x. That means I'm going to have a smile bending around here. It'll say plus 8x. I'll show that. Plus 8x squared. You can check yourself. Minus 6 plus 8x squared gives you 2x squared. What mistake will people make in here? They will put 8x squared rather than just 8x. But you've got x squared, you've got a planet x term, and then a constant term on the end. Now, that's not the end of the question, because you still then have to go back to lesson 6, as it were, and factorize this bracket. I've got nothing in common, so you need 2 sets of brackets here. So we're just showing you here what happens when you factorize on there, okay? So I didn't do the factorizing bit there, but that's the bit you could factorize first. A question here, sorry, an additional maths question with a full issue with finding the remainder, and then b.u1 show that it's a factor, so we know straight away we have our first factor. So I will leave you a minute or two to see if you can work on that. Okay. And the first bit says x minus 3, so I've subbed in 3. I've shown my workings how it is done. Gave me 70 for 2 marks. Mark for subbing in 3 and a mark for getting the answer. Show that x minus 1 is a factor. We're going to substitute in 1. And we've got to expect the answer 0. And if we don't get 0, we have to check our workings. It did give us 0, so x minus 1 is a factor. Now, hence factorize this. So this is where we get back to the idea. We have x minus 1. We've got to get our smiles in. So I've done x minus 1. The first smile gave me minus x squared. The second, and I needed 5x squared in the answer box, because it says 5x squared there. Minus x squared plus 6x squared gives me 5x squared. Then I still need to factorize this one. It's pretty straightforward, factorizing B grade GCSE maths. Again, every school will show their own slight variation, but I know 2 times 4 makes 8. So I knew it was going to be 4 and 2. Now, they just say factorize. At A level, they ask you to solve them as well. Sometimes they might ask you to solve, very rarely. All the past paper questions I've done, nearly all have been factorized. If it said solve, that's when I had the previous early examples. If it did say solve, I'd say x equals 1, x equals minus 4, or x equals minus 2. Okay. Now, that's a quick recap on the lessons, and now I've got some new resources, as I said here, that you won't have seen on exercise 5, 6, or 7. And I've mixed them around. They're not all in order. I've just mixed around the topics. So I'm starting with a remainder and a factor theorem question. So I will pause for a few minutes and let you have a work through that. So I put my solutions up. Okay, so the first bit is divided by x minus 2. Now, there are different methods of doing this. I was taught in school to do long division, but I find that a lot more complicated than subbing in a number. So I'm just going to sub in 2. Gives me an answer of 47. You won't find those are honestly satisfactory answers, all the questions I've done. They'll get some strange answers. As long as you can substitute incorrectly, it's easy enough for 2. Show that this is a factor. Now remember substituting minus 6, and remember when you substitute in minus, be careful with using brackets. I think there's 4 fairly nice marks there. Equals 0, I'm convinced I've done that right. Sometimes I tell my classes to start on B.E1 first, just in case they're not sure whether to substitute in 6 or minus 6. If they substitute in 6, it wouldn't give them 0, so they know they've done the wrong thing, because to be a factor, it's got to equal 0. And now for the final 4 marks, the trickier part. Again, I'll give you a bit more time to have a think about that. I know the first factor is x plus 6. Again, additional maths, all the questions start with x cubed. A level, they start with 2x cubed, maybe, or 3x cubed. Additional maths, they seem to always just start with x cubed. So this one, first of all, I'm looking for x squared in the answer box. The first mark gives me 6x squared, and I need x squared. So 6x squared, then I know it's going to be minus 5x squared will give me x squared, or 1x squared, or plus 1x squared. So if that's 5x squared in that smile, that means it's going to be x times minus 5x, give me minus 5x squared. And then, as I say, because they start with x cubed, you'll find in additional maths that the second set of brackets is just B grade GCSE maths. Now this one is a little bit nasty, and you'll see I've actually, I believe, put the wrong answer in. Now I don't know if you can work out why I've put the wrong answer. There's a couple of reasons why this one's gone wrong. That should say, see, I've said minus 3 times plus 2 is plus 6. And then I've also said minus 3 plus 2 is minus 5. So I have made a mistake. That should say x minus 2. That would have cost 1 of the 4 marks. It's not a deliberate mistake. And that's a mistake I've just spotted when looking at this now. Okay, so follow my words rather than my pictures there. X plus 6, don't forget to put the first factor in. And then you're looking for 2 numbers that multiply to 6, and that's subtract to minus 5, and that should be minus 3 and minus 2. Next page. This one's to do with completing the square, as it says at the top. So I'll let you work your way through that. Okay, so half of 40 is 20, and 20 squared. Remember, you can use a calculator in additional maths papers. In fact, you could be able to use a calculator for additional maths and all A-level papers are calculator based. So x plus 20 squared, remember, take away the 400 to counteract that work. Plus 100 gives us this. Now, if you watch my early videos, I often make a mistake on these. I often do the wrong thing the wrong way around, so I'm going to read this properly. The minimum value occurs when x equals, and I always think the 300 first is the first thing I look for, but I've got to read the question again. The minimum value at the bottom that's the one that's minus 300, and then one when it occurs when x equals, this x equals is quite important. Now, I have checked this with the examination board, and if I did put the numbers in the wrong way around, I would have just dropped a mark. So it's minus 20 from that same plus 20, because that equals 0, and that's minus 300. So I'm just telling you there, make sure you put them in the correct order. Next question. Now, this one is actually a recap of something I did in one of my videos from last year. I think it was video 3. But it involves factorizing in the long run. So find the points of intersection. Now, if you've watched videos 5, 6, and 7, you won't have seen anything like this, but there's two equations, both beginning y. Put the two of them equal to each other. So write 5x squared minus 8x minus 6 equals 10x plus 2. Then do some ordinary, I would call it fairly straightforward A grade GCSE maths to get to factorizing that point. You'll see I've just shown quick slide. I had some smiles in there just to show where the smiles would come in. That's why I put this question in, just as a recap of something before and show you where else factorizing would be used. So say put the two equations equal to each other. And before you can factorize, I said on one of the earlier slides today, you've got to get the equation say equals 0, and you will be doing that on this one. So I'll stop and see if you can work on that before I put my answer up. In 10 seconds, I'll put my answer up. 3, 2, 1. Okay. So the reason I put this on is to show you the reasons where factorizing will be used. Factorizing is used in so many topics in additional maths and also in A-level maths. So if you don't learn factorizing, you need to do plenty of work over to reflect for this summer's exams. So I said put the two equations equal to each other because they both say y equals. Then I did make the point you've got to say equals 0 before you can factorize. I said that earlier today, but I've highlighted again this one. There's quite a few additional, A-star GCSE maths questions that don't always say equals 0 on the end, when you've got to get them to say equals 0. So it's good practice of that. My school, I would write an arrow down the middle and say take away 10x from both sides. And then I've got to factorize this. Now it starts with 5x, so I would always start with 5x and x. It's a prime number on the front. I've got 8. So I would try 1 and 8 or 2 and 4, but as I say from my experience, it's normally 2 and 4 rather than 1 and 8. And if 2 and 4 don't work, then try 4 and 2. This smile gives me 2x. This smile gives me minus 20x. And the answer box has to say minus 18x because it says minus 18x there. Now, I haven't totally finished the question yet because it does say find the points of intersection. And all I've actually done is a factorizing bit. So now I'm going to carry on and show you how you solve them, which you've seen earlier today. We're going to get x equals from these two brackets. So if you've not done that yet, I'll pause for 10 seconds or so, give you a chance to do that, and then we'll see what else we need to do. Okay. And this is what I've done. 5x minus equals minus 2, because 5x plus 2 equals 0. X equals minus 2 over 5. X minus 4 equals 0, so x equals 4. And if you're wondering where I got those values from here, all I did was substitute these x values into y equals 10x plus 2. I could have substituted them into the top, 5x squared minus 8x minus 6 as well, if I wanted to check I've got the right answers to see that they're the same for both. But substituting to this top one on the right is a lot easier and a lot quicker. Everybody can do 10 fours plus 2 is 42. Okay, 10 times 2 fifths, maybe not as easy. So you will see questions like that because that's on every year's paper as well. And if you want any more evidence of that, look at my last year's additional math slides on the recordings folder on the e-sgol website. Now, this is a fairly recent exam question. It's totally different sort of factorising. I think this would have caught a lot of people out just because it is different. And all the additional maths papers, there's normally 17, 18 questions, 15, and 2 or 3 are totally sort of brand new that I'd never seen before. But a lot are quite very similar in content and look, but this one looks a bit different. So it says, first of all, show by factorising that it's a product of 3 consecutive numbers, hence give the answer. So I will stop after this first bit of the line by factorising. Now, you should have seen questions a bit like this in A grade GCSE maths. But I'll let you think about that bit first before I will put up the whole answer. Now, what I would say is these both have something in common, so I need one set of brackets, and they both have an n in common. So I would take n outside the brackets, then open brackets, and leave me with n squared minus 1. So n open brackets, n squared minus 1 is the product of 3 consecutive factors. Now I'll rewrite it. Hence, given that equals that, find the values of n. But if you realise n squared minus 1, you might have been told the term dots or difference of 2 squares. N squared minus 1 will factorise into n plus 1, n minus 1. And then really it's a case of finding 3 numbers that are consecutive to each other that multiplied 120. So you could do that by trial and error. 2 times 3 times 4 is 24, no good. 3 times 4 times 5, 60, no good. 4 times 5 is 20 times 6 is 120. That's the theory behind it. Here's my write-up. So first thing, I've taken n out as a common factor, left me with this. Now in theory, I could work it out from here. I could find the numbers that work, but say, depends what you've been shown, but difference of 2 squares, and there's plenty of these on the higher tier mathematics papers at WJC, GCSE, and that splits into n plus 1, n minus 1. Okay, you could do n minus 1, n plus 1, and then it's a case of finding 3 numbers. So here are my 3 numbers. And if you're wondering where I got that from, I've just substituted straight into there, but I've also done it from here as well. So I've said n is 5. I've done 5 squared, 21. Really, the top line's the key bit, but it's just making sure I find the value of n. Make sure I don't put in the wrong number by mistake of putting 4 or 6, or even putting 4 times 5 times 6. So that's why I put the 5 in there. So I thought I'd show you that question. It's slightly different. And so a lot of additional maths paper questions are the same, but whenever something's slightly different, always throws a few people. So here's my next question. Just a generalish factorised question. Not the easiest because 27's on the front, but 5's on the back, and nice, that's a prime number. So I'll let you have factorise of that. So I'd split 27 to 9 and 3. But I know there's lots of methods, and some of you might use the method where you do 5 times 27 first of all is 135. But then I find that sometimes slightly harder because it's awkward to find what goes into 135. There's no perfect way for factorising, but it's important you have a strategy that works for you. So I'll now put the answer up in 5 seconds for dotty 1. Okay, I said I'd try 9 and 3. And then I've tried 5 and 1. I could have tried 1 and 5. If I try 1 and 5, 1, 3 is 3, 5 9s are 45. 3 and 45 aren't going to get to me to 6. 5 and 1, 5 3s are 15, 9 1s are 9. 15 and 9 will give me the 6 if I take away. Okay, that's for 2 marks, hence solve. Just be careful with complacent errors that I made. I've shown you I made one earlier. I don't believe I've made one on this one. 3x minus 1 equals 0, x equals a third. I've just gone in, I've jumped 2 steps in one quick go. Minus 1 will change to 1 and divide by 3. But the number of times you see people write minus 1/3 there. So just be careful of the mistakes. Said I made one earlier. This one, plus 5, take away 5 from both sides and divide by 9. So a lot of that is your higher tier maths recap. Not many higher tier maths questions start with number 27, but I think there's one out that starts with 14. Let's see what the next slide is. Okay, so now we have another completing the square one. I think this one's written out a little bit nicer than the previous one I showed. It's easier, what they sort of lay it out easier so you know what you're going to answer each time. I'll stop and let you work through those. Okay, so the first answer's coming in now. Half of 10 is 5. 5 squared is 25, so I counteract that 25 by taking away 25. That does say plus 35. Works out as 10. So I'm just going to point out this classic mistake I see when marking these sorts of papers. You'll often see people forget the squared, so they lose 2 marks straight away. You'll often see people put x plus 5x because they halve 10x to 5x. It's not that, it's half the coefficient. And if you really want to check, you can multiply out x plus 5 all squared, FOIL it out, and see you'll go back to the original number. Okay. So hence find the least value. As I say, I prefer this one. It's easy for me to get my head around. The least value is definitely going to be 10 because it says 10 on the end. What is the value of x when it has its least value is minus 5. Sorry, it's slightly hidden at the bottom of my PowerPoint. Why? Because x plus 5 all squared is 0. X plus 5's got to equal 0, so x equals minus 5. Nice laid out question, that one. Now, when I did my completing the square video for session 5, I deliberately kept this question for the revision session on the end. We haven't done one quite like this. I think this was a 2022 or 2019 paper. Yeah, when I've used this in my school, yeah, they found this a little bit different. So first of all, by completing the square. Now you'll notice all the completing squares we've done, I've just said all on one side. They don't say equals 0, but you've got to take everything to one side. So what do I mean by that? The first thing you're going to do is write down x squared minus 22x plus 5. Okay, by completing the square. Well, you notice completing the square, all the questions we've seen so far have not had an equals in the middle. So you just drag it all to the one side. So that's the first thing I'm going to tell you to do for 2 marks. Go and complete the square on this one. I've broken my solutions down into parts. So, and if you're wondering why I put a tick there, that's to show what I got a mark. So as I've said, I brought it all to one side. Now, solve, whenever you solve, you really want your final line to say x equals. And generally all the factorizing we've done, we need to put them equal to 0, as we've seen a couple of questions today looking at that. And we saw find the points of intersection. There it says put them equal to 0. Now, the next thing, I just gave you a quick introduction to what you do the next line. You've got to tidy this bit up. So you're going to end up with x minus 11 squared and minus 116 equals 0. Now, this is the whole point of completing the square, to help you find maximums and minimums of graphs and find some solutions. So your next line you're going to do is that. X minus 11 squared equals 116. Then I've square rooted. Now, hopefully you're familiar now with doing higher order maths. The square root of 25 is no longer 5, it's plus or minus 5. Up to GCSE, generally it will be just they'll accept 5 unless they say write all the solutions. But as we get on to additional and A-level maths, the square root of 25 is not 5 anymore, it's plus or minus 5. Square root of 49 is plus or minus 7. So, just recap what I've done so far. Drag this all to the left-hand side, put it equal to 0, then did my completing the square skills, tidy that up to say minus 116, but I've got to solve it, which means I've got to get x on its own. To that stage, I got 2 marks, and the final 2 marks come in a second. See if you can go and do those, because there's a classic mistake people make in a few seconds when they say x equals x minus 11 equals that line, and trying to get x on its own. It does say insert form, and you can use your calculators to simplify that surd down. Now, this is 11 plus square 2 square root of 100, and it does say in third form. So if you press square root of 116, it would have told you it's 2 root 29. And here's the third and the fourth mark where they come from. Okay, so that says minus 11. When you bring it to the other side, remember it says 11, not minus 11. And you split them into 11 plus and 11 minus. Okay, so that's I believe the only question I've seen since 2012, since this exam paper's sort of existed in this form. I think that's the only one I've seen with a complete square where it says solve. So again, I've tried to pick out a couple of questions today that are slightly different to what you might have seen before. Next one, back to the factor and remainder theorem. So I think that's quite a nice 4 marks. And then the factorizers on the next slide. So if you want to have a look at an example, stop the tape now and look back and find a question. There's not that many examples today, so it's fairly easy to find which one's which. Right, so I'm going to sub in 3. It gives me 99. And the next one, show that x plus 3. Again, I've said earlier, I might start with b dot u1 to make sure I'm subbing in the right number. I'm going to sub in minus 3. Don't just put equals 0. You've got to show a little bit of work in here, because everyone knows in theory it should be 0. You don't need to put my final line, but I just like to summarize what I've done. Equals 0 is the key bit. We're showing some work in. And say this is the final slide. Hence factorize. Now just go back a slide. Hence factorize. It's the same question. So we know our first bracket is going to be x plus 3. This is 4 marks like they generally are. I think so. It's got to start, the second bracket's got to start with x squared, leave a gap for the smiles, and then how many 3's make 105? You can always use your calculator if you can't do that straight away in your head. And my answer will be appearing in about 10 seconds. 3, 2, 1. Okay, so let's just run through that. 3x squared gives you that smile in the answer box, so I need x squared, because that says x squared. I need x squared there. So 3x squared, I need to say minus 2x squared. So x times minus 2x will give me minus 2x squared. It's type 1, you've got to think, don't make a mistake and write 2x squared there, it's just 2x. And it's quite an easy one to factorize on the end. There's only things that multiply 35, 7 and 5. And 1 and 35, but I very rarely use 1 in these. Generally, these questions seem to use the 2 other numbers. Okay, so hopefully that's a good recap on 3 topics. To say there are 7 sets of videos, and realistically, there's only about 13, 14 topics in additional maths anyway. So there's plenty to get you going. But as I say, there's a lot of factorizing in additional maths and A level, so it gives you a chance to sharpen up and show you a couple of different strategies for that. Hope you enjoyed my videos. Good luck with all your work.